Here's an example of a problem where I'm trying to find the height of a mountain. Now we've done similar problems to this using some basic SOHCAHTOA stuff. In this situation, I'm going to show you, and while there's a few ways to do this, I'm going to show you a different way besides just a simple SOHCAHTOA problem to find the height of this mountain. And so in this particular situation, if you can look at the diagram, we're given a few different pieces of information. We're 2 meters tall. We're taking the angle of elevation of this mountain as we stand 900 meters apart. And so that's the information I'm given in this diagram. Well, what I've done is I've gone ahead and I'm going to look at this problem as two separate triangles. This green triangle over here, which I've redrawn at the bottom, and for ease of discussion, I've labeled those vertices A, B, and C, and then a purple triangle as well, where the height of the mountain is located. So what I'm going to do is I'm actually going to begin with just that green triangle. And my first step is going to be I want to find side A, this side over here. Well, I've gone ahead and, like I said, redrawn the triangle and included some information. However, there's some more angles I can figure out with this problem using some basic geometry stuff. For example, looking back at the diagram up at the top, I'm going to find this angle next. I know that these two angles next to each other make a straight line, so they have to add up to 180 degrees, meaning angle B in my obtuse green triangle needs to be 133 degrees. The reason I wanted to find that is because now that I know two angles in the green triangle, I can find this top angle as well, because the angles in a triangle all need to add up to 180. So subtracting those two angles I know from 180 tells me that angle C is going to be 12 degrees. And so let's go ahead and use the information I have now in the green triangle to find side A. I'm going to do this using law of sines because I do have a matching side angle pair. I'm going to begin by matching up angle C. So sine of 12 to side C, which is 900, that 900 meters along the bottom. And I'm going to use the proportion then, sine of angle A, which is 35 degrees, over side A, which is, like I said, the first side that I'm going to find. Now there's, like I said, alternate ways to do this problem, but this is the way that I saw, this is the way that I wanted to do, so I'm going to go ahead and do it this way. So doing some cross-multiplying, solving some proportions here, I'm going to get approximately 0.2079a when I do the sine of 12, equals about 516.22. And again, I assume you're fine to do this using your calculator and just double checking my work here. Dividing then by 0.2079, I find that side A comes out to be approximately 2,483.02. So that's not my answer, but that's going to be a key step in solving this problem. So let's go ahead and, well, if I kind of see where that goes in the original triangle, that's this side here, side A, which also happens to turn out to be the hypotenuse of that, well, now red triangle. So let's now go ahead and move on to phase 2 of this problem. Let's go ahead and redraw that red right triangle. Alright, so magically there is my now red right triangle redrawn. So I've included the 47 degrees, the angle that was formed right there, and then I found, as we did in that first part of the problem, I found side A, which also so happens to be the hypotenuse of this right triangle. And since I'm now dealing, like I said, with a right triangle, I can do basic SOHCAHTOA stuff to find the height of that mountain. So taking a look at what I have, here's my angle. I know the opposite side and I know the hypotenuse. So this tells me I'm going to be working with sine. So I'm going to say the sine of 47 degrees is equal to the height, not the hypotenuse, the height of the mountain, the opposite side, over the hypotenuse, which is 2,483.02. Using a calculator to solve this, I find out that that height of the mountain comes out to be approximately, if I round to the nearest whole number, about 1,816. But then one minor detail just to keep in mind with this problem, that is the height of the triangle right there. But recall, if you had read the problem or we mentioned it very briefly, we're already standing 2 meters tall for our instrument that we're measuring it from. So actually, I suppose I should probably add on that extra 2 meters that I'm standing to get a total approximate height of the mountain of about 1,818 meters. So there's alternate ways to this problem. I'd encourage you to try to find a different way if you could, but that's kind of how I saw. I'm going to start with law of sines and using that obtuse triangle there, find the hypotenuse of this second triangle, and then finish it with some basic SOHCAHTOA right triangle trigonometry.